All right, so let's look at similarity. So we're going to go through these notes. What do you notice first about all the new side links? We're trying to dilate the triangle by a scale factor of 2. All right, the way we would do this, like we did yesterday, we'd find the center and find the rise or the run to get to each point. So I'll call this just A, B, C, just to kind of be clear here. So going up 1 and then over to the right 1 for A. That means I would double. So I'd go up 2 and then over to the right 2 for, we'll say, I'll call that A prime. And then I'll say I go up, looks like 3 into the right 1 for B. So I'll go up 6 into the right 2 for B prime. And then I go up 1 into the right 3 for C. So I'd go up 2 into the right 6 for C prime. So I'd have my new triangle would look something like this, where it is landing like that. All right, so what he knows about all the new side links. Well, let's see. I had links of, looks like 2 and 2 for right here for AB and AC. Now my new links are 1, 2, 3, 4, and 4. So I'm guessing we are doubling, right? So we got the scale factor of 2. The side links should all have doubled. So side links should have doubled. All right. Looking at the next couple examples here. Here we have similar and not similar. So an example and then a non-example. So what does it mean for two shapes to be similar to one another? Take a second and look at those. Let's see. So I would say, so type it on here. We'll go a different color. So what does it mean for two shapes to be similar? First, all of my similar shapes, all of these similar shapes should have the same angles. So we'll see here that we got 53.13 and 90. Right, if I were to take away both of those from 180 to find the third angle, it would be the same third angle of, I don't know, would that be 37.87? So I'll write those in here. Right, if I were to do 180 minus 90 minus 53.13, that would give me 37.87. So both of those angles are the same down here in the bottom right corner. So I have all three angles are the same. Also, we see that we have each proportion should be the same as well. So like for here, if I said like 3/6, that would be the same as equal to 4/8. So 3/6 is equal to 4/8, where the same relationship is like 1/2, where I am setting those up equal to proportionally. Right? So we have the same right there. Also, if I were to double, right, 5, it'd be equal to 10 as well. So I see that kind of doubling relationship with all of those. That's two things that make it similar. Not similar, we got these angles aren't the same, and then also we have 2 is double to be 4, and then 2 is not double to be 3. So we have those two things that are going against us to be not similar. We can also see, look at the slope right here of this line. That slope's going to be different than this slope right here. So we got two different slopes. All right, proportion refresher. So create some equivalent fractions. In this case, I could say 3/6 or 4/8, where I'm just maybe doubling, tripling on the top 1 and tripling 2 to make it 3/6. All of those are equivalent fractions. How is this like similarity? Basically, we're using the same scale factor. So we are using a scale factor to figure out these proportions. So like what I did here, as I took 1/2 and I multiplied times 3 on the top and bottom to get 3/6, right? And then the same thing, I said 1/2 times 4 to give me 4/8, where these are all equivalent to 1/2, right? But they're just being scaled up. So if I wanted to complete this proportion, I get 2/3 is equal to x over 9. In this case, I would have to multiply times 3 to get to the bottom. 3 times 3 would be 9, so I'd multiply times 3 to get x equals 6. Another way we could do that is through cross multiplication. So I had 2/3 equals x over 9. I'd cross multiply and say 3 times x is equal to 18. Divide by the 3 on both sides, you get x is equal to 6. So either way works to figure out that proportion. All right, moving on, we got triangles ABC and DEF are shown, which the following is equal to the ratio BC over AB. All right, so we got BC is right here, this, and then AB is right here, this side of my triangle. Which one is equivalent to that? So this one is all about the angles. So my 32 degrees is given down here. This would be 32 up here, and that means this would be 58 up here. So it looks like BC is across from the 32 in this triangle. So across from the 32 in this triangle would be DF. So that would be on top of, because I got BC's up here on top, so DF's up top. And then AB looks like that's across from the 90 degree. So I'd say across from that would be DE. So I'd say DF over DE. Next one, let's see. What is the value of X and Y? So I'm going to stop there and come back to it because I had a class coming up. So to be continued.